Welcome to section 5.1. There's a couple types of problems that we have to work on for this quiz here. One of them is where they tell us some information and ask us to find the tan and the cosecant for that information. The information that they give us does two things. It tells us which quadrant we have to draw our triangle in, and it tells us the side of the lengths of the sides. So let's start out by trying to find where the cosine is negative and where the sine is less than 0. Being less than 0 tells me that the sine is negative. I know that this is going to happen down in quadrant 3. The reason I know that is I use all students take calculus, and if the tangent is the only thing positive, all of them are positive here. The sine is positive there, the tangent's positive, which makes the sine and cosine both negative. So I'm going to draw my triangle over here. I know that I'm going to have a triangle that looks kind of like this. And the cosine is the adjacent over the hypotenuse. So I'm going to put a -1 here. The hypotenuse is +4. And so I'm going to be looking for this side. I'm going to use Pythagorean theorem to find that. And I'm going to say -1 squared plus b squared equals 4 squared. I get 1 plus b squared equals 16. B squared is 15, square root, square root. When you square root, you get positive or negative here. Which one are we looking for when we're going down? The negative one. So I'm going to label this negative square root of 15. Now that we have our triangle drawn in the right quadrant, we're going to answer our questions. First question, find the tangent of theta. Here's my theta. And so the tangent is the opposite over the adjacent. So I'm going to have the negative square root of 15 over -1, which gives me just a positive square root of 15. The cosecant, I'm not sure what that is, but I know that 1 over the sine, or the reciprocal of the sine, will give me that. So I'm going to find the sine and then do the reciprocal. The sine is the opposite over the hypotenuse, so I'm going to have the square root, or negative square root of 15 over 4 is the sine. So I'm going to do the reciprocal of that, which gives me 4 over the negative square root of 15. Because we're looking for a final answer, we need to rationalize. And I get 4 square roots of 15 over -15. Could I move the negative out front or up top? Yes. Where the negative is doesn't matter. There's an answer. There's our other answer. Now let's take a look at question 32. 32 says the cosine of x over the secant of x plus 1 plus the cosine x over the secant squared minus 1. Since these two denominators both look like they are the conjugates of each other, I'm going to find my common denominator by multiplying them together. When I multiply a binomial times a binomial, I need to FOIL. So when I do that, I get secant squared x minus 1 is my common denominator. To get my top, I have to take the cosine here times secant x minus 1. Over here, I need to multiply this cosine by the secant x plus 1. When I distribute this, I get cosine x secant x minus the cosine plus cosine x secant x plus the cosine. And that's all over my secant squared x minus 1. Then what I want to do is I want to try to simplify here and here, because they are opposites of each other, leaving me with 2 cosine secant, I get 2 cosine x secant x all over the secant squared minus 1. If I do my substitution, I know my identity is tan squared plus 1 equals secant squared. So when I substitute in here, I'm going to substitute here. I'm substituting tan plus 1 in for the secant. So I'm going to do that. Tan squared x plus 1 minus 1. The plus 1 and minus 1 go away, and I'm left with down here the tan squared x. So now I'm going to rewrite this as 2 cosine x times the secant is 1 over the cosine x, not squared. Cosine on top, cosine on the bottom, they go away. So I'm left with 2 over the tan squared x. And moving that up to the top, if I had a little more room, I'd have 2 cotan squared x. Well, let's try number 40 now. Just like Brian said, I'm going to leave a little time on the recording here after I'm done doing it for people to continue. 40 says the cotan x over the secant x minus the tan x. All right. What I want to do here is I want to change, if I'm not sure, I could multiply by the conjugate here, because that's one of the ways to get rid of 2 terms on the bottom. But before I do that, I'm going to try to change these into sine and cosine to see if that's going to help. I might be going down the wrong road, but there's plenty of going down the wrong road on these. Try whatever you can. 1 over the secant is 1 over the cosine. Tan is the sine over the cosine. Looks like I have a common denominator here, so I'm going to rewrite that as the cosine x over the sine x, that all divided by 1 minus the sine x over the cosine x, which is the same as writing cosine x over the sine x times the reciprocal of this, which gives me the cosine x over 1 minus the sine x. And if I simplify that down, I'm going to get, I need some more room here, I'm going to have, again, the cosine squared x over sine times 1 minus the sine. And I'm not going to distribute that because I have a pretty good idea that if I do a plus 1 minus 1 here and then do some substituting in here, I'm going to end up with 1 minus the sine squared. Sorry, I should have showed you. I'm substituting in here. In for the 1, I'm putting in, let me put it in green, sine squared x plus cosine squared x. In for the negative 1, which makes that negative and makes that negative. My negative cosine squared and my positive cosine squared, they go away. And I'm left with the 1 minus the sine squared. So that's what I did. I did a plus 1 minus 1 to get this. And then, back to blue, I have a sine over 1 minus the sine of x. If I remember right, this would be, when I factor it, because it's the difference of squares pattern, 1 plus sine x times 1 minus sine x. The 1 minus sine x, 1 minus sine x, they cross out, and I'm left with, in blue, I'm left with 1 minus the sine x, or 1 plus, all over the sine of x. And to make that just a little bit simpler, I'm going to change this into a secant on top of x times 1 plus the sine of x. If I thought this would be any simpler by distributing it, I would certainly do that. And we can, and it'd probably be a little bit simpler to write it as the cosecant x plus sine x cosecant x. Sine x, this is 1 over the sine, so I'm left with the cosecant x plus 1, because this is 1 over the sine. And that's about as simple as we can go for that one. All right, thanks and good luck.